So now let's talk about misconception 4. So what does it say? It says recognizing denominators as the number of equal pieces instead of number of equal groups. What does it mean? The wording is not clear. So recognizing denominator as a number of equal pieces. So that's if we have 7 pieces altogether, we say the denominator is 7 because it's a powerful relationship, right? Number of pieces represent the denominator. That's right. That's good. That's right. But also, denominator can mean the number of equal groups. But a lot of times kids don't know. They know the number of equal pieces can be denominator, but they don't know number of equal groups also can be the denominator. But this is an important concept of the equivalent fraction. That's why they need to know both number of equal groups can be denominator, at the same time number of equal pieces can be denominator too. So here, let's talk about the top picture here. How many chips do I have? I have 1, 2, 3, 4, 5. And how many of them is red? So my denominator is number of equal pieces. So 1, 2, 3, 4, 5. So my denominator is going to be 5. Then how many of them is 1? Red? 1. So kids can easily see this is 1/5 because I have 5 equal pieces, which is my denominator. One of them is red. No problem with this. What about this? Can you say this is 1/5 too? Because we know the equivalent fraction and how to find the equivalent fraction, like times 5, like that. We know that it's 1/5. But a lot of times kids might say, no, this is not 1/5 because I have 25 things in here. 1, 2, 3, 4, 5. 5 times 5, it has to be my number of equal pieces is my denominator, and then 5 is my numerator. So this is 5/25, not 1/5, because I know the denominator means number of equal groups. So I don't know how come this can be 1/5 as well. So that's misconception. Now how can you show to kids this can be 1/5 too? Because we can make the same number of groups, right? So you can make, how many groups can you make? We have 1 group, 2 group, 3 group, 4 group, 5 group. So how many equal groups do we have? We have 1, 2, 3, 4, 5 equal groups. So my denominator can be 5. My denominator can be 5. That means I have a number of equal groups. And how many groups out of 5 is going to be is red? Is 1. So I know that they are the same, right? So set model, this is the set model. We are using the set model in here to represent equivalent fraction. So kids need to know that denominator means number of equal pieces, like this, but also can be number of equal groups. So that's why that's why they are the same in here. Even though I counted by 1, it is 25, but you can make equal groups, and equal groups can represent denominator too. So it's going to be 1/5. Okay, so this is the misconception kids have. So how to support kids? Use manipulatives to teach equivalent fraction conceptually. So we're gonna talk about 3 different models because we learned that there are 3 different fraction models. The first one is area model, length model, and set model. So this is the set model with the chips. The set model, usually the whole is bigger than 1. And then this is the area model, like we use fraction strip. We can use fractions, we can use paper folding, and you can use pattern block. There we are talking about the area, size of the shape. That's all area model. And we can use a fraction strip. That means you can look at the length of each fractional piece. Then you can think about them as a length model. So I'm going to show you how we can represent equivalent fraction using area model, set model, and length model. So this is the way you can show the equivalent fraction to your students. So first we're going to talk about the area model. So what is the area model? Area model, we're talking about the inside of the shape. So that's what we see. If the size of the shaded part the same, we say that they are equal in size. Because we are looking at the size here. So we can also use a fraction strip to compare the size of each piece too. So that's the area model in here. So this is fraction, parabola here. So this is 1, right? This is 1. If this is 1, this is 1. How do you know? They look exactly same in size. If this is 1, this is 1 as well, right? Because they look exactly the same. If I cover this on top of each other, they look the same in here. Then, but the sizes are smaller for each piece. This one is 1, but this one is what? We have 2 halves, right? So we have 1 half plus 1 half, same as 1. What about here? This is 3, 6. There are 6 triangle in here. So it's going to be 6 groups of 1, 6. Same as all 1. Right? What about half? I want to just use the compare. I want to find the equivalent fraction of half. And I'm going to have this. How do you know they're the half? The size of each piece the same. So this is half. They're the same in size. So I know that they are equivalent fractions. So what do you mean by the equivalent fraction in area model? That means they are the same in size. So I have 3 groups of 1, 6. So we can say 1 half the same as 3, 6. And what does it mean? This is what it means. They are the same in size. I have a 1 half, 1 piece, but I have 3 pieces of 1, 6. They are the same in here. That's the equivalent fraction concept. What about this one? We can also think about the area. So I have a 1 whole and 1 half. They look the same. This is 2/4 and this is 4/8. They're all same. How do we know they're the same? If I cover 1/4 2 times here, it's going to be the same in size. So if we want to compare the size, we're looking at this fraction strip as an area model. But I want to look at the length of each figure. So I have the 1 half in here, 2/4 in here. They look like they're the same length. From here to here, they look the same in length. So this is how we can say the equivalent fraction. So let's write it down. So I know that 1 half, the same as, how many fourths in here? 2/4, same as 1, 2, 3, 4, 4/8. They're all equivalent fractions. So what do you mean? How are they? Because oftentimes kids think they are not the same because they're 2, 4, 8. All the numbers are different. How come this can be the same? So what does it mean? That means they're all in the same in size or same in length in here. But set model a little bit different. Set model means same in the ratio, that's equivalent fraction. I'm going to show you shortly. So this is equivalent fraction in here. So I want to talk about one small activity you can do in your classroom to talk about equivalent fraction. So any piece of paper is fine. Just take a piece of paper looks like this. Just cut it out, any recycled paper, whatever. Just cut it out, the paper looks like this. Any rectangular shape is fine. And suppose that this is 1. Okay, then I want to represent 1 half using this. How can I do that? Maybe I want to fold it in half, like this. Does it matter which side I fold, this way or that way? It doesn't matter. So I want to fold it this half and draw a line like this, and I want to shade one side. So this is my fraction here. So how many equal pieces do I have here? I have 2 equal pieces, right? I have 1 and 2. 2 equal sized pieces, but one of them is shaded, so I know this is 1 half. Does it make sense? I wanna fold this one more time, like this, and then open it, and I'm gonna draw a line. So now here, when you look at the shaded part originally, the size of shaded parts changed or not? No, the shaded part remained the same. The size of shaded part didn't change. But I have a smaller size pieces here. So how many equal size pieces do I have? 1, 2, 3, 4. And how many of them are shaded? Yes, 2 out of 4 is shaded. So my answer is going to be one half. When I counted only like this, 1 and 1/2, 1 and 2, 1/2. Well, I have a smaller size piece here, but same shaded part. 1, 2, 3, 4, same as 2/4. What about 4/8? I'm gonna fold it one more time, right? And I'm gonna open it, and I'm going to draw a line. Okay, like this. So does the shaded part has changed? Size of shaded part changed? This is originally shaded part, it never changed. But we keep cutting into smaller and smaller pieces here. So how many equal size pieces do I have now? So each box represent now 1/8 because I have the same equal size 8 box. 1, 2, 3, 4, 5, 6, 7, 8. And how many of them are shaded? 1, 2, 3, 4 of them are shaded. So I know that it's going to be same as 4/8. So this is one way you can show the kids so they need to understand what does equivalent fraction means. Also, they need to find out using formula. But formula is important, but conceptually, they need to understand what equivalent fraction means, right? That's the important part. So now let's talk about, so this is the area model. This is, you can use it as also area or length model, both of them. So same in here. They want them to find out what's the same as 1/3. So they can kind of compare the size of each shape they have. For example, they want to use this one. They're not the same. How do they know? They're not in the same in the size, also they're not in the same in the length. What about I want to put one more here? Are they the same? No, they're not equivalent fraction. Why? Because they're not the same in size. They're not the same in length. So they're not equivalent. That's why we know this is not equivalent fraction. What about this? Oh, I think they're equivalent fraction. How do you know? I have 1/3 and 2 groups of 1/6. They're same in length. Looks like they're the same in length. Also, they look like same in size. If I overlap it to 2, exactly the same in size. So that's how I know 2/6 is the same as 1/3. Okay, good. So now let's talk about the set model, the last one. Set model is a little bit different because usually area model or length model, we have one, it means one piece, one whole piece, right? So this is one, like this. But set model, there are multiple whole set, can be a set model, set here. Let's talk about here. So one, I have 1 and 1. What's this? 1/2. So how do I know? There are 2, 1, 2 is my denominator. Number of equal size, equal piece, denominator, and the 1 is red. What about this? Do you think they're the same? They're at 1/2 too? 1/2 or what? If I count individual chips, it's going to be 4. And how many of them are red? So I'm going to 2/4 is going to be the same, right? So that's equivalent. Let's do one more. Okay. So what about this here? How many equal pieces do I have? 6. And how many of them are red? 3. So this is the one we talk about, that number of equal pieces. So they need to know this, but they also need to know that they are, how come we can say this is 1/2 same as 1/2? We can find out equal grouping. So I have how many equal groups? I have 1 group and 2 groups. I have 2 equal groups and 1 is the red. Same thing in here. I have 2 equal groups, 1 group has 3 chips, and 2 equal, so I have 2 equal groups, and then one is them is red. So we can also say it's 1/2. So set model, the equivalent fraction means ratio. They have same ratio. Okay, so area model, they have the same area, size area. Length model, they're same in length. That's the equivalent fraction meaning. Okay? That's it for the fraction misconception activity. Thank you for watching.